Hello everyone, we are at Beyond the Formula. Let's continue conic sections with ellipse. So let's see the definition or how an ellipse is generated. Suppose I have two pinpoints, say A and B, and I have a thread. This is a thread tied at points A and B, right? Now to generate an ellipse, I tighten the thread, suppose like this. Now this is the thread when it is tightened. Now if I move this point, suppose let's say this point is P point. If I move this point P in the whole plane, what is the shape that it will generate? It will generate such kind of shape, right? It will generate this kind of shape where at every point, suppose this point, if I say this point, every point on this figure, in this figure, this will have a constant distance. What? This distance plus this distance. Suppose this is L1, this is L2. Here also it will be L1 plus L2 will be constant, right? L1 plus L2 will be some constant, and that constant will be length of thread, right? Now let's see, this is the geometrical definition of ellipse, how it is generated, right? So once we have generated the ellipse, let's see some parameters. These are the 2 points, say F1 and F2, and this is the ellipse. Right, this is the ellipse. Now these 2 points F1 and F2 are called focus. F1 and F2 are called focus or foci. So we have F1 comma F2 as foci of ellipse. Now the constant distance, this L1 plus L2, this point P. If I say take the point P and put it here. So the distance will look like what? The distance will look like F1P plus F2P, right? F1P plus F2P. Now let's see here. The distance will be right like this and like this, right? So we have this distance 2 times. If I take this distance and put it here, right? So we will have F1P plus this distance, suppose this is Q. So we will have this as F1P plus F1Q, right? Which is equal to this total length, and which we say as 2 times of A, which is called the major axis, of ellipse. Now we have this, the vertical axis. We have this vertical axis as minor axis, whose length is 2b, right? So let's see the coordinates of all the points now. So we have ellipse, we have focus F1, we have focus F2 with coordinates c comma 0 and minus c comma 0. We have this point as a comma 0, this point as minus a comma 0, this point as 0 comma b, and this point as minus b, 0 comma minus b, right? Now we need another small formula here that we will derive simply. So we have this distance as b, this distance as c, and suppose this distance we need to calculate, right? So see here, if I join this here, so we also have this distance as c, this distance b. Now you see this point, suppose say this point is p. Now p lies on the circle, correct? P lies on the circle, sorry, ellipse. P lies on the ellipse, which will satisfy f1p plus f2p equals 2a, correct? P lies on the ellipse, which will satisfy f1p plus f2p equals 2a. Now we have f1p. In this case, in this special case, we have what? We have f1p equals f2p, right? We have f1p equals f2p, which will imply that these are equal to a. So we have f1p equals f2p equals a, correct? Now using Pythagoras theorem, what we have? We have c square plus b square equals a square, which implies a square minus b square equals c square, right? This is the result we will require further. Now let's move to the equation part.